Hey all, welcome back to the channel. In this video, I'll tackle something that's been on my honey can you list for a while now from my wife. See, she uses this pasta roller to roll out clay for her small jewelry business. Along the way, the handle of the thing broke, and it's been falling apart piece by piece over time now. So in this video, I'm going to try to take a look at it and see what we can do. So if we look at the original handle, we can obviously see it's busted and in pretty bad shape. These two pieces look like they were friction fit together, and the plastic itself has relatively thin walls that broke under my wife's Herculean grip. I'm not exaggerating, she's low-key kinda jacked. Anyways, to start I'll take some calipers and try to get some key dimensions I'll need to design a replacement. For those unfamiliar, calipers are used to make relatively small and precise measurements. The battery's died again. Yes, but great at small, precise measurements, and in particular for more cylindrical objects where you want to measure inner and outer diameters. After measuring that the outer diameter of the crankshaft was about 7.5 to 8 millimeters, it immediately reminded me that I have some ball bearings that would be perfect for this job. A ball bearing is simply two different sized rings, conjoined but separated by these little balls that allow one of the rings to rotate even if the other is fixed or stationary. You've likely seen them in everyone's favorite fidget toy, the fidget spinner. See the little balls inside here? And when you give it a spin, I hold the center ring stationary while the outer ring and the toy itself rotates effortlessly with relatively minimal friction. Anyways, measuring the inner diameter of these ball bearings I have on hand, I know that they are basically perfect in size to use as a means of coupling our handle replacement on the crankshaft here. And a short break here to say hi to a guest on our channel, our dog Winry. She's really the bestest girl and loves her head scratches. Bonus points to anyone who knows where that name is from. After getting some of those key dimensions and deciding on the coupling method, I figured I should probably take a second to figure out how exactly it is I'm going to design this thing. What made the most sense to me at the time was to design something that is relatively similar to what the original handle had, including some of those ridges to add a nice little bit of extra grip. We'll also design it into two separate interlocking pieces to allow me to pop the ball bearing in and then conjoin them together using some kind of adhesive. Alright, a couple quick disclaimers here. First, I am not a cat expert. I know enough to get the job done, but will very likely make some of my friends pull their hair out if they're trying to watch some of this. I did decide I need to start using something a little bit more robust than Tinkercad, so I settled on Fusion 360, at least for growing a little bit. We'll see how this goes. 2. Admittedly, I totally forgot to get any footage of designing the first half of the handle. Oops. So here it is in all its glory. I created a cylinder with 8 more or less equally spaced ridges around its sides. Through the center we have a recessed cylinder that goes about halfway through it to accommodate the bit of the crankshaft on the other side of the ball bearing. And lastly we have this recessed bit to house the ball bearing itself with a 3mm thick wall that will then interlock with the second half of the handle. After exporting it as an STL, I tossed it into Prusa Slicer to create the G-code that will ultimately get sent to the 3D printer. I always admire this post-slicing view where you can see each of the individual print lines it generated, as well as a tabulated breakdown of what the extruded filament will ultimately be used for, be it the infill, exterior, supports, etc. It also gives you a pretty decent estimate of the print time this will take. So let's go ahead and fire up the printer and get this guy cooking as we design the second half of the handle. Here's a quick status check on the print. For those a little unfamiliar, solid objects designed in CAD are often not printed that way because it would take an incredibly long amount of time to print. So instead, we specify an infill, usually some kind of geometric grid kind of like this, with a volumetric percentage of how much infill we ultimately want. So far so good on the print though, so now we'll move on to the next piece of the puzzle. Alright my mechanical friends, here's where you'll probably want to skip ahead. I hold no liability for premature hair loss and urge you to move on if incompetency is a trigger. With that out of the way, CAD is both surprisingly easy and frustrating as hell to learn. The basic gist for those that aren't familiar, and as I, a lowly software engineer, understand it, is that you first start with a 2D sketch as a known reference point. You create it basically as if you're looking straight on at whatever it is that you're trying to make, specifying all the different dimensions and shapes you want to find. Once you complete that sketch, you bring it to life in the 3D realm by choosing from a few options here, such as revolve, extrude, etc. Then you make more sketches, either from that global coordinate system starting point that you had at the beginning, or referenced off of a side of what you currently have added. As you can see here, I went ahead and sped up the recording of this to not bore you with too many of my redos. Essentially for this part, I need to redesign one end that would interlock directly with the first half, but also apply pressure on the ball bearing to hold it firmly in place. The other side would ideally be made conical to avoid any sharp edges and just give this an overall better looking appearance. The ridges would also need to be re-added and align with those of the first half. Lastly, a recessed cylinder would be placed to remove all of the material in the middle to allow the crankshaft to fully move through the center of this half. Admittedly, it took me way too long to figure out how to do all of this, especially adding the recess that interlocks with the first half of the handle. But we powered through and created something resembling more or less what I thought I had in my head. I was even able to add a nice fillet to the other end, which I think looked pretty nice and gave it that nice polished look. Once we export the file and toss it into Prusa Slicer, we gotta figure out how to best print this as it requires supports based off of its current geometry. So I'll go ahead and enable that feature and get it oriented in the way that makes the most sense to me, which is to avoid support material at the interlock to prevent that connection having issues that need adjusted for later due to built up filament. So now we'll go ahead and start that print. Edit. Midway through the print, I noticed that at like midnight, I forgot to account for the 7mm thickness of the ball bearing at the center portion of the interlock and the second part of the handle. So it'll actually need to be flush with the outer wall of the interlock like so. After fixing that, I restarted the print and went to bed. But now, an ad from our sponsors. Coffee. That was my attempt at a joke. Back to the video. Now that we have both sides of the handle printed, we'll go ahead and take the first half and pop the ball bearing into it and make sure it has a nice, snug fit. For the second half, I decided I should probably do a fit check on the crankshaft. Lo and behold, it's a little tight. So we'll have to get our files out and get to work. After conjoining the two halves of the handle, I noticed that there is a small gap that I would like to have removed to try to make sure that this is about as seamless as it can possibly be. For sanding this down, I decided I have a better tool for the job. My orbital sander. It's basically a faster file, right? So after tossing the piece in a padded vice grip, I got to work. As you can see, it's definitely at an angle. And, to my baffled surprise, I just melted the plastic away instead of removing it. Apparently, friction generates enough heat to melt PLA. Who knew? So after getting some side snips and some files to get off all that melted plasticky goodness, we tried a fit check again and got a much better seamless look. Now for the adhesive. I used some Zap-A-Gap glue and filled the interlock here basically like a little reservoir for all of this stuff. Pro tip, it works great and cures very fast, but do not get it on your hands. After combining the two pieces together again, I went ahead and put it back in the vice grip to let it cure for a few minutes. To get this onto the crankshaft as the fit was still pretty tight, a simple rubber mallet worked great to pop the bearing and the rest of the handle on. After grabbing the pasta roller, we went ahead and gave it a spin. And lo and behold, it actually worked pretty great. A little stiff, my guess is the inner diameter could still use some plastic removed to allow a little bit less friction, but all in all, really not too bad. So that's the video. What do you guys think? Obviously some key takeaways on my end that I really ought to take some Fusion 360 courses to better bring my visions to a reality. It's probably the biggest struggle of this whole thing, and honestly what made me delay in tackling it for a while to begin with. All in all though, the result is about what I pictured it would be in my head, even with the minimal amount of experience that I do have, so hopefully that doesn't scare some of you off from doing your own personal projects. Additionally, trying to learn a little bit more about tolerancing of things, like for example, even just adding 1/10 of a millimeter to that inner diameter just to give myself a little bit more clearance would have been pretty helpful. Also, don't use a orbital sander to try to sand plastic. Hopefully this educated some of you or inspired you to tackle some of those lingering projects that you've been putting off for too long. Odds are, if you're like me, the hardest part is just starting and trying to give it a go, even if you feel like you don't know what you're doing. Ultimately, you may be surprised to find that it's only a fraction of as difficult as you're making it up to be in your own head. As always, if you have any questions on what I did, or would like me to go more or less in depth in the future on certain aspects like these, or just any general feedback for me, let me know in the comment section down below. Or if you have even some of your own projects and you would like some advice, or my 2 cents, I'm always happy to help you out. Just feel free to reach out. Till next time, smell ya later. Or something. I don't know.